Okay, let's take a look at number 28. The instructions here say that we must translate the sentence into an equation and solve, and then write a sentence that answers the question. Now the first thing I'm going to do is to read what sentence we need to translate. And I see 7 more than twice a number is negative 15. More than, keywords. Twice, keyword. Is, keyword. A number. I guess everything's very important here. Let's see. For the number, it's unknown, so I'm going to call it x. Is means equals, and we need to equal this to negative 15, whatever comes before. Now, 7 more than twice a number. I see twice a number as 2x, and I want 7 more than that number, so I must add 7 to it. To continue, we must solve for x, that means isolate the variable, add the opposite, add negative 7 to each side, so that we can clear the constant. 2x plus 0 equals negative 22. Divide each side by 2, and we get x equals negative 11. So that's the number. What is the number it says? We can write the number is negative 11. Number 29 and 30 are both word problems, and actually they both come from section 3.6, so I should cross this off and write 3.6. And let's read and understand the problem. Oh, before we do though, our instructions tell us to set up a legend, draw a diagram, which isn't required, but we must identify a formula, and of course then write and solve an equation. And we write the answer as a sentence. One step at a time though. Let's go ahead and look at the legend first of all. Well, actually first read through the problem, then we'll set up the legend. 2 photocopiers were used to create 350 copies of a brochure. Now it sounds to me like we've used them together and that this number right here is the total. So we'll keep that in mind. If the older machine created 80 fewer, it says less, but it should say fewer. If the older machine created 80 fewer copies than the newer machine, how many brochures did each copier create? All right, so what we've got here is a situation with 2 unknowns. And whenever that happens, when we set up the legend, the second unknown mentioned is always going to be our variable. In this case, x. That's the one that I use. So I can right away say let x equal the number of copies from newer machine. And I'll abbreviate that a little bit. And that means that our other unknown is the number of copies from the older machine. From the older machine. And we have to figure out what that is going to be. The older machine created 80 fewer copies. That means we have however many the first one created minus 80. And it makes sense that the older one would be slower and create fewer copies. Now from this, our formula is actually the generic formula, which says that we must consider the sum of the parts, which in this case is the newer machine's copies plus the older machine's copies, equals the total. The sum of the parts equals the whole. And so this allows us to set up our equation. X from the newer machine plus x minus 80 from the older equals the total of 350. And before we do any clearing of like the negative 80 in this case, we must combine x plus x like terms. 2x minus 80 equals 350. Let's now go ahead and add 80 to each side. And it looks like we have here 2x plus 0 equals 430. When we divide each side by 2, we're going to have to do some long division, but we find out that x equals 215. I'll let you do the long division to demonstrate that. So what we have discovered is that since x represents the number of copies from the newer machine, that is 215. In other words, 215 copies. If we subtract 80 from that, we get 135. And just a quick check, do they add up to the 350 total that we're supposed to get? Let's find out. 5 plus 5 is 10. Carry the 1. 2, that's 5. Not carrying anything, 3. 350 total. Good. So we feel comfortable and confident about our answer. Let's go ahead and write a sentence. In fact, I actually have the sentence already written here. And you can see the newer machine created 215 copies and the older machine created 135 copies. Those are the numbers we got. Okay, number 30. It says here the perimeter of a triangle is 53 inches. Well, a triangle is something we can draw. So let me just put 3 sides. It doesn't really matter how accurate we are with these. We'll just draw 3 sides. Nothing special. I'm not trying to imply any particular lengths here. And we are told that the first side is 18 inches. So let's make this one right here 18. And the second is 7 inches less than twice the third. Oh my goodness. Wow, that's a lot. 7 inches less than twice the third. Now that's the second side. And so because we have 2 mentioned, one of those is going to be x, and I think it's, well, it has to be the second one mentioned. That's x. So 7 inches less than twice the third. Let's just call this x. I don't know if that's supposed to be where it is on the diagram. Again, it doesn't matter. We're just using it to understand the situation. So we're going to let x equal the third side. Let x equal third side. And what that really means when I say third side is the length of the third side. I just didn't write that. Now the second side, how is that going to be represented? Well, we have to go back to that sentence of comparison, which says the second side is 7 inches less than, or shorter than, twice the third. Twice the third is 2x. 7 inches shorter means minus 7. Second side. 2x minus 7. And we have a formula. We have the perimeter is 53 inches. Let me just write that here. Perimeter equals 53, and we know that it's inches. And in a sense, the perimeter formula is the same as the generic formula, the sum of all the parts equals the whole. But I'm simply going to write it as first side plus second side plus third side equals the perimeter. And what values do we have here? First side, that'd be the 18, plus the second side is the 2x minus 7. The third side is x, and the perimeter is 53. So now we have this equation to solve, and we're going to combine like terms. 18 and negative 7, or 18 minus 7 is 11. 2x plus x is positive 3x. So I'll say plus 3x. That equals 53. Again, to solve, we add the opposite. In this case, we're going to add the opposite of negative 11. We add negative 11 to each side. And what we get is 3x equals 42. Let me scroll up a little bit. Bring that up a little bit anyway. 3x equals 42. Now we divide each side by 3. Divide by 3. and I'll let you do the long division, but it turns out that x is equal to 14. Now again, let's go up and look at our legend. X is 14. That means that our third side is 14. And the second side is 2 times 14 minus 7. That's 28 minus 7, that's 21. So our second side is 21 inches, our third side is 14 inches, and we were asked to find those two sides. And here we have it in sentence form. The second side is 21 inches and the third side is 14 inches. And don't forget the word inches. Number 31, find the greatest common factor. There are a few ways to do this. I will show you a couple of them. One is to find the prime factorization of each number. 56, first of all. We might recognize that as 7 times 8. And 7 is prime, but 8 can be broken into 4 times 2, and 4 is 2 times 2. So we see that 56 equals 2 times 2 times 2 times 7. 42, let's see how that breaks down. Let's see, that's 6 times 7, well there's 7 again, and 6 is 2 times 3. So 42 is 2 times 3 times 7. To find the greatest common factor, oftentimes abbreviated as GCF, we match up one at a time. Here's a pair of 2's, though the greatest common factor will use just 2 to represent both of those. 3 does not match up, but the 7's do. 2 times 7 is 14. And that's the greatest common factor, which is what we're looking for. I'll write that off to the side here. GCF equals 14. And I'm going to show you another technique. So if you want, you can pause and read this a little bit longer before you go on to the new technique, but I'm going to erase now. Another technique is to write them side by side and to divide one number at a time. We see that these numbers are even, and so we'll divide each by 2. 2 divides into 56 28 times. 2 into 42 goes 21 times. And now we look to see if these have another factor in common. And between 28 and 27, between 28 and 21, they do. They have 7 in common. So we divide out 7. We get 4 and 3. And the only thing that 4 and 3 have in common is the factor 1, which means we don't need to consider taking it any further. What we have found along the side here, though, are the prime factors. So we can write that as GCF equals 2 times 7 equals 14. The same number we got doing it the other method. The same answer we got using the other method. Number 32. We have a single fraction which seems like it's got a lot going on here. In the numerator, we have 18 times h times k. And in the denominator, we have 54 times h squared, which is h times h. And you'll see why I want to write that out as h times h, because we can divide out a pair of h's. Every time we divide out a common factor, we can write a 1 in its place. But the k and the h cannot divide out, so that's complete. 18 and 54. Trying to think of a number. 6 divides into 18 and 54 evenly, so let's do that. Let's divide each by 6. 6 divides into 18 3 times, and 6 divides into 54 9 times. Now, because we've got so much going on here, I'm going to take a look at what we have before we continue on. In the numerator we have 3 times 1 times k, that's 3k. In the denominator we have 9 times 1 times h, or 9h. And I know the k and the h cannot divide out, but you know that 3 and the 9, we can take those further. So let's do that. 3 divides into 3 once, and into 9 3 times. Now we've simplified it down to just a single k over 3h. And that cannot be simplified any further.